Hello class, this is a video tutorial on calculating the mean, but it's going to be from a frequency distribution table. As you can already see, there's a little bit extra what you'd normally see on a frequency distribution table. So normally it's just this here, isn't it? With a total at the bottom. In order to help us calculate the mean, you can extend a frequency distribution table with an fx column. What this fx column means is if the score, which is labeled x, so these are all our x scores, and f is our frequency, so this means 4 happened 3 times, 5 happened twice, 6 happened 4 times, and so on. So if we were to write this out in an extended form here, 4 happens 3 times, so it's going to be 4, 4, 4, then 5 happens twice, 5, 5, then 6 happens 4 times, 1, 2, 3, 4, and so on. But there's no point rewriting it out like this. We'll just keep it out in this version here. It's actually much easier to interpret. So in order to calculate the mean, so we know the mean as x bar is equal to sum of scores divided by number of scores. Okay, so let's figure out first how many scores are there. Well, if these are indeed the scores, but as we said, 4 happened 3 times. So it would be 1, 2, 3. 5 happens twice. Okay, so that means there's 5 numbers so far here, because there's 3 4s and 2 5s. So in summary, if we just add all these up, we get the number of scores here. So we'll do that now. 3 plus 2 is 5. 6 and 4, well 4 and 6 make 10, so that's 15. 15 plus 8 is 23. And now, if we were to add 4 3 times, 4 plus 4 plus 4, isn't that the same as 4 times 3? So this is actually what the fx column is for. It's so that we can just multiply these out and just add these once we're finished. Okay, so 4 times 3, well that's 12. 5 happened twice, so that's 10. 6 happens 4 times is 24. 7 times 8 is 56. 8 times 6, well 6 8s are 48. Adding all these up, we will get our solution. 2 and 8 make 10, carry the 1. 4 and 6 make 10, so there's 2 extra here. 2, 4, 6, 10, that's 15. That's 150. And in case you're doubting that, you can go ahead and grab your calculator and use that. So now we know that the mean here is going to be 150 over 23, which will give us, that I cannot do, over 23 is going to be 6.52. And I'm just rounding that off to 2 decimal places. Okay, we'll go ahead and do this next example here. Well, if you can't quite see it, we can actually extend this in this direction here. Or we could just rewrite this in this. We could rewrite this into this format. So I'm going to go ahead and just do the one that you're more familiar with. I'm just gonna go ahead, rewrite this as our standard frequency distribution table. So here's our X, that's our F, this is going to be our F, X. Here we are. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Same length. Our scores are 23, 20, 25, 26, and 27. Our frequencies are 5, 8, 9, 12, 13. And we'll first go ahead calculate. So since we're going to be calculating the mean, I'd like to get this number first, the number of scores. So we'll go ahead and calculate that now. That will give us 5 plus 8 plus 9 plus 12 plus 13. So we have 47, 5, 8, 9. Yes, good. That is 47 scores. Okay. Now we'll go ahead and calculate the FX column. 23 times 5. Get some more viewing angle for you here. 23 times 5. That's 115. 24 times 8. 192. 25 times 9. That's 225. 26 times 12. 312. 27 times 13. 351. Adding all these together, 115, 192, plus 225, 312, 351, gives us a total of 1,195. So our mean would be 1,195 over 47, which will give us 1195 divided by 47 as a decimal. That will give us 24.43. That's going to be as 2 decimal places. 2 decimal places. Okay, so I hope that gave you a good outline on how to calculate the mean from a frequency distribution table.